Hello, welcome. This is the third video of a C++ beginner tutorial. Last two videos we discussed cout. We talked about arithmetic, mathematics, how to do mathematics in C++. We talked about plus, minus, multiply, divide, and parentheses. And we talked about some peculiarities of divide and also the modulus operator. Okay. Modulus operator, by the way, has many uses. One of them, you can, for example, the quickest way to check if the number is even or odd would be try to mod that number by 2 and see if you have a remainder of 1 or a remainder of 0. And that would quickly let you know if the number is actually divisible by 2. But anyway, I digress. So this is a new topic, and this is where I'm going to introduce something called variable. Okay, you might be familiar with the word variable from mathematics. Okay, in math we a lot of times use x and y and z and alpha and beta and those kind of things to represent numbers that could be there, right? To represent some unknown. Well, here it's not exactly the same. We don't represent unknowns per se, even though, well, they are unknown in a sense. But basically, what a variable is some kind of letter or a word that you can use to stand for something else, like a number. Okay, so you could like designate x and say that it'll be equal to like 26, right? And your program will from now on remember that whenever you say x, what you mean is 26, right? So you can have these kind of, you can have it stand for some value, okay, some kind of some number or some word or something or other. So let's go ahead and take a look how that's done. Okay, in C++, variables have types. Okay, they have what's called a strong type. They have so that means that each variable has to be specific as to the kind of things that it could stand for. For example, one of the most common types of variables is an integer variable. Okay, integer, and for short we write it as int. Okay, in C++ we use the word int to represent an integer or a whole number variable. Okay, a whole number variable can only stand for whole numbers. Okay, that means no 2.5, no 0.56, none of that. It has to be whole numbers, and that's your limit. All right, all it can stand for is whole numbers. Okay, so the way we create a variable is we just specify its type. In this case it's int, right? And then we give it a name, okay, like the x. Okay, I just made that up, literally. I could have called it y, I could have called it z, I could have called it I could have called it j, I could have called it anything I want. In fact, I don't even have to use one letters. Like, the reason I called it x is because that might be familiar for you from math, but the truth is that you can actually name your variables with anything you like, any word you like, you can stick in there. And like, for example, I want to name my variable number of people. Okay, that's perfectly acceptable. Okay, that's actually very good, very acceptable, because in programming we actually try to name our variables meaningfully so that whatever they stand for is what's written on a variable instead of x, because you're going to be, having a hard time after a while remembering all your x's, because there's going to be way, more than one. So, but for right now, let me just go ahead and call it x, just for for quick reference, and then I'll start using the more proper names for our variables. So again, you see this line ends in a semicolon, like I told you before, because semicolon is like a period. It finishes the statement. Okay, and this is a statement right here. This whole thing is a command, and what it says is, I know it's kind of a shorthand, but C++ is mostly like that. It's concise, because otherwise there's already too much stuff to write. So we're trying to limit the number of letters we have to type, literally. So instead of saying make a variable that is able to hold a whole number and named x, we just write int x. Okay, we just write int meaning make an integer variable, and x would be the name of that variable. So after I created that, like starting at line 8 right here, okay, starting at line 8, the computer now knows that x means some unidentified whole number. Okay, now unidentified though is a problem, because like, what happens if I just say cout and then I tell it to print out x, right? Now notice that I did not use quotation marks for the x. Okay, because what I wanted to do is I wanted to look at the x, figure out what it's equal to, and paste that number right here. Okay, so I wanted to evaluate X. I don't want it to print the letter X. I wanted to figure out what X means and print that. Okay, but there's a problem because you see we created a variable, but we never told it what it should stand for. We only told it that it can stand for whole numbers, but we didn't tell it which whole number it is we wanted to represent. So as a result, what's going to happen is it's going to print out what we call garbage. Okay, and let me show you what that looks like. Okay, see this? The number 4200814. This is a total random garbage. The reason that the way that came to be is it's basically some residual numbers that were stored in a computer's memory that were never cleared, and that's what's coming up because what we did here is we used what's called an uninitialized variable. Okay, because the variable was never given an initial number that it should stand for. Okay, the initial value. So the computer basically took a garbage value and printed it out. So what you should do is once you create a variable, okay, now you can use it anywhere in your program, right? Anywhere in the scope of these brackets, this one and this one. Okay, so you can use it anywhere. Now, the way we make a variable stand for certain things is we just write its name, which is X. Okay, that's what we named it, and then we put this equal sign down and we give it a value like 34, and again we terminate our line. Okay, so this is me saying I want X to equal to 34. Okay, now this is kind of very important to understand. This is not exactly the way you're used to using the equal operator in math. Okay, because in math your equal sign basically affirms that something is equal to something else. In programming, the equal sign means I want to make it equal to that something else, okay? And the direction matters, okay? The direction of this sign matters. For example, if I were to write 34 equals to X, okay, this would actually be an error, okay? This would be a problem because 34 is not a variable, okay? So it would be like you can't make 34 equal to anything but 34. Right? 34 is already 34. However, X is a variable. Okay, the key word here is variable, which means it varies, it changes. So right now we're changing it to 34. And so right now from this line 8, X is equal, whenever X is encountered, what the computer is going to read it as is 34. Now, if on the next line I go ahead and change it again and I say X should now be equal to 26 or 265, whatever, right? So now X is equal to 265, and the fact that it was once equal to 34 is now forgotten, right? We don't care about that anymore. So if I print this out, what it'll print is 265 because that's the last value that we assigned to X. Okay, by the way, that equal sign that I keep talking about is actually not called the equal sign, it's called the assignment operator. Okay, and the way it works is it works from right to left. Okay, let me re-emphasize that point, from right to left, not the way you write in English, but the other way, from this end to this end. That's how equal sign works. So first the computer looks at what's on the right side, not on the left side but on the right side, and figures out what's happening on the right side, whether it's just one number or maybe it's a mathematical expression that's long, but it figures out the result on the right hand side. Then it takes that result and assigns it to the variable X. So after that, variable X has this new value. Okay, all right, so this is how we can create variables. We can add stuff to, we can calculate their value, and then we can print out their value. Okay, and of course you can do all sorts of little things, like you can have plus this times this. You see what I did there? I just started typing a random mathematical expression. But what's going to happen is this line is going to first 34 is going to get written to X, right? Then this stuff is going to get calculated and written to X, overriding the 34. And then the result of that is going to get printed out. All right? So if you want to see what the result of that is, let's go ahead and run. And here's what we have. We have, wow, that's very lucky, huh? 1300. I didn't think it was going to be exactly 1300, but I guess it is. I guess it is. Never thought about that. I was not prepared, I swear. I just kind of typed some random numbers where my fingers were sitting, and I got back the exact pretty round number. Huh. Okay, so anyway, this is what we can do with variables, and we're going to talk more about variables in the next video. Okay, see you then. Bye bye.